Hey everybody, David the AI Guide here. Welcome to another episode. Thanks so much to our new subscribers. I really appreciate that. And also be sure to like, subscribe, and share videos with your friends. And let's keep in mind the real purpose of the AI Guide, which is making AI human. So what do we mean by that? We mean that there's millions of articles about AI all over the place, but all it does is tell you technically what something is able to do. It doesn't try to tell you what the human impact is going to be of these technologies, and that's what counts, really. I mean, what counts is, does a specific new breakthrough in AI make your life better, easier, or faster without putting people out of work? Or does it make your life better, easier, and faster while putting people out of work? Or does it make your life more complicated? And so there's, it can be any of those. Today, we're going to do a quick refresher, which I think is important because there's a lot of terms that are used interchangeably in the press about AI, and it can be confusing. And it's really important to understand the difference in the core technologies that are being discussed in all the articles that are out there these days. And we'll talk about why it matters in a moment. But the two biggest terms that you see in media stories is machine learning and deep learning. And deep learning is a subset of the broader area of machine learning, but they are different and they do different things. So machine learning uses an algorithm that has to be specifically trained to do a certain task. So in the machine learning world, to do that training, what they do is label a bunch of examples with exactly what they want the algorithm to look for. An example might be an algorithm written to find broken bones on an X-ray. So what they're going to do is feed a lot of X-ray examples to the algorithm, and the ones where there is a bone broken, which is some is not going to show a broken bone, so that the algorithm can learn the difference. But for the ones where a break is present, they're going to label it and say break. And the algorithm learns to recognize what a break is and what is not a break so that it can accurately read X-rays for that purpose. That is a perfect example of machine learning, and it's called supervised learning, meaning that a human is involved and that the samples are tagged with what you want the algorithm to learn. Deep learning is different. Deep learning does not use a very specific algorithm like regular machine learning uses. It uses a neural network, and that neural network is capable of finding commonality in a bunch of examples. So you will see the term unsupervised learning, that's deep learning. You will see convolutional neural network, that's deep learning. And deep learning strength is that you do not have to train it, and you can give a neural network a bunch of different examples, and it will learn from all those examples what sticks out and what that thing that sticks out is. So, for example, it's much easier for a neural network to learn what is a dog than it is to train an algorithm to recognize what is a dog, because dog, you have to give a lot of very specific examples, and what is a dog, what isn't a dog, the ears, the legs, the tail, etc., etc., etc. Whereas a neural network fed a lot of examples that have dogs in it will become able over time to learn what a dog is versus a person. So deep learning performs well on much higher level tasks, and machine learning performs well on very narrow specific applications. And it depends on what you're trying to do, whether you use machine learning or deep learning. So let's say, for example, that I am a quality manager in a factory, and I want to train an AI to look for a kind of flaw in the product that we make. Machine learning is going to be great for that. Why? Because you have a specific material, you have a specific flaw you're looking for, you're able to give it very specific examples of what to look for, and the algorithm will learn to find those examples and then notify you when it finds a quality defect. In high production environments, this can be very useful, right? Let's say that you're running something in a factory that is 500,000 pieces, which is a large run in a factory. And you're running it on machines that are running at high volume at high speeds. Training a machine learning algorithm to find a quality defect rather than having people standing there doing it will allow you to A, have better accuracy finding the defect, and B, speed the process up specifically, because machine learning tied to computer vision can find quality problems of a specific type in a process running at a much higher rate than a human being can. So this is a really good example of why you would use AI in a specific situation and why it would be better than a person. So the reason in this example is obviously higher speed equals higher efficiency equals higher profit for the company making it. Let's move on to something different. Let's say that you are teaching, you want to create something to be able to read MRIs. And MRIs are used for many different types of disease identification. And so to use machine learning, regular machine learning for that, where you have labeled samples and supervised training, would take a very, very long time, because you're looking for, let's say, 15 different diseases in one scan. That is very difficult to do using traditional machine learning. This is a situation where deep learning will work very well. Why? Because you're going to feed 1 million MRI results into this deep learning neural network, and it will learn what is a cancer spot, what is emphysema, what is an infection, what is whatever it is, right? So in this situation where you have multiple potential things to be identified, it's much more efficient to use deep learning. And deep learning learns on its own with feeding unlabeled examples into it. So this is why people talk about deep learning versus machine learning. They're both good. They're both good for different purposes. And perhaps they're best in combination, right? Because let's say that your focus is cancer and maybe a specific type of cancer. So you create a machine learning algorithm and give it labeled examples, but at the same time, you analyze the same images with a neural net that can pick up things other than what you're looking for. So again, perhaps using these two related technologies together will provide the best result. So we'll see. But hopefully this makes it a lot more clear about what machine learning is versus deep learning, supervised versus unsupervised. And of course, neural net is a deep learning term, just like convolutional deep learning neural net or deep convolutional neural net. This is why, for the general public, I try to cut through the jargon and bring you clarity on what people are talking about and why it's important. So in these examples, the reason it's important is that it will make a process much more accurate and or efficient, or it will find multiple problems in a given situation. A perfect example of that, again, is if a patient has an MRI, it could well turn out that within that one MRI series of scans, the patient could be identified with having multiple disease issues. So this makes healthcare much, much better. Machine learning makes healthcare much, much better also. So this is why these technologies are important. Again, for the purposes of the AI guide, what's important is alerting you to what technologies are specifically going to be used to displace humans from jobs and provide you resources to go a different direction so that you're protected. That's our mission. So thank you for tuning in for this explanation. And there's a link below here where you can get a free resource to learn much, much more than what I just explained about machine learning, deep learning, and AI in general. And it's totally free, so dig in. Thanks so much. Take care. Talk to you next time.